Grab a clean board there, and a marker. Settle down, Washington. We have high schools here that are represented in large numbers, and they tend to talk amongst themselves, and they feel very comfortable doing that. But we got a lot to cover today. Nick asked earlier, what if we get done with this assignment today? We're going to do stormwater. The dilemma I had was, I had a second assignment for you to do, but the other class didn't finish the first assignment. So your job is to focus and get this done. This is not Hazen Williams. In other words, it's not quite as complicated as it was a week ago, but it's still a lot of math. So if you don't have your phone and or calculator out, please put it out on the desk in front of you right now. Phone or calculator, either one. I need to see one in front of everybody's desk, because we will be doing some math here, and we don't want to waste a lot of time. Now, it's easier to learn if I kind of set you up with a question, you guys can pick off the answer. So if I say to Alex, I go, Alex, what is the answer? That just really narrows it down to one person, right? But if I say, everybody, what's the answer for this question? You can all write it down on your whiteboard, hold it up. I'll say, good, good, try again. Try again if I say that. Otherwise, we'll move on to the next question. All right, so stormwater is something that we have to deal with all the time. Big picture. You guys are all designing houses. You got your house set up on a hilltop right now, right? A lot of you? Alex, what happens when it rains and that water runs off that hilltop? Where does it go?
On the bottom of the hill?
Yep, and to your next door neighbor. So the idea of stormwater is you want to capture the water and not have it release off your site at a greater rate than it did prior to your development. Let me say it again. You want to capture the water so that it doesn't discharge at a greater rate than it did prior to development. So if it's a farm field, discharges 10 CFS, by gosh, it better be discharging 10 CFS when you're done developing that site. Okay? So that's all what stormwater is about, is capturing water. Right now what happens is it goes into the ground, into the street, into your neighbors, as Alex said, but you want to hold it on site in a depressed area, either a wet pond or a dry pond or maybe underground storage. Site development, we have different ways to deal with stormwater. We also want to protect what? Alex, yes Alex, what do we want to protect?
Our neighbors.
Yeah, our neighbors and the environment, the bigger neighbor, right? For water quality and sedimentation. So, watershed characteristics. These are important things to think about. Is what type of soil do you have? Jason, if I dropped a bucket of water on this right here, and I had a factor between 0 and 1, 1 being impervious, solid, or 0 being total absorption, air, if you will. If I had a bucket and I dumped it onto another bucket, the bucket would represent what? 0 or 1?
1.
Right, 1 because it's a solid object, right? But it turns out pavement is 0.95, because you do get a little credit because there is some cracks in pavement where the water goes into the joints. But a lot of what you're going to be doing today is about pavement, rooftops, and soil in the farmland. So there's regulations that are used to calculate, and there's a simple regulation that they use called the rational method. So we're going to run through the rational method and have you do a few calculations on your whiteboard. Q equals CIA. So what we got here is, when you're doing this work today, it's very important that you all take the time to follow the methodology of engineering, which is given and find. Every one of your journals should have given and find. Given being the things that you're told about the item, and find what you're trying to find. What we're trying to find today is the difference in Q, the runoff. We're trying to find what the post runoff is versus the pre-runoff capture on our site. There's a factor for recurrence adjustment. What's happened over time, you guys have heard about global warming and all the hubbub about how the rain has changed. Well, they've adjusted these factors here at a 100-year storm, being a big storm. What size storm did we have, Nick Saunier? What kind of a storm did we have in 2008 in Cedar Rapids? What year, what magnitude of storm do you think that was? 500? Is that what you said? 500-year storm. Good call. So yeah, it was greater than a 100-year storm. So it was a big storm. What we deal with is intensity, depth over duration. All right, so let's do this. Everyone on your whiteboards. I have a 6-inch storm, and I have a 2 hours. 6 inches, 2 hours. Write down what the intensity is. 6 inches, 2 hours, what would that be intensity-wise? Good, 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 good. Everybody got that, right? Everybody got 3? Very good, very good. So that's all intensity is the depth over the duration in hours. Design storm is usually dictated by the regulators. So the local regulations might say, you gotta detain the 100-year storm, which the 100-year storm has a 1% chance. Jack, a 10-year storm has what percent chance of happening any given year? A 10-year storm has a what percent chance?
10% chance.
10% chance. You guys remember that from before? We covered that before. 10% because a 5-year storm has a what chance? Trent?
20%
20%
chance?
chance. So it's pretty simple, right? 1% for 100. 500 years,
So it would be
0.2.
theoretically possible to have 5 or 6 500-year storms in a row?
That's right. Every given year, there is a chance for that same storm to occur or variations of storms to occur. That's why people said, why do we need to build a levee down on the river? Because this happened, it won't be another 100 years or 500 years before it happens again. It's not true. That actual storm could happen the very next year. Do you remember what happened last year? We had water backing up in the streets because the storm can happen again. It just depends on the rain. Here's a rainfall intensity map. This rainfall intensity map is what they used to use to pick off how much rain you might get in a particular storm in a particular area in the United States. We are using this table today. So on your whiteboard, back to Nick's comment, the 500-year storm, 1 hour. Write down the 500-year storm, 1 hour on your whiteboard and show it to me. 500-year, 1 hour, good. Not quite, try again, good. Get your numbers reversed there a little bit. Good, 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 good. Get your numbers reversed. We're looking right here. Everybody got 3.21? Good job. Let's try one more. I know this is hard to see, but I want you to think about, okay, 25-year storm, 10 minutes. 10-minute intensity, 25-year, how much inches per hour are we going to get? 25 years, 10 minutes. Good, good. Try again. Good, 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 good. Try again. Good. Try again.
Oh.
Good. It's hard to see, but it's a 25-year, 10-minute. It's right here. You got. If you get mixed up here, you got 25-year, 10 minutes right there. You just happen to go on the next line. That's fine. So you'll be using a lot of these charts today in your activities. This is the same chart, only graphical form. So you can see here, 10 inches for a 1,000-year storm. You go back and slide, 10 inches for a 1,000-year storm. You get the idea? So you can show it 2 different ways. Which one would you guys prefer to use? Would you rather pick a point off of this, or would you rather use a table? Table all day long. So that's why these charts are mainly to show generalities between different storm events, not necessarily something you would use. So let's go through an example. This is where you guys can help me out. I just bought this farm, and I have 3 acres. And I'm going to do this with you, but I want you guys to get the answer with your calculators. So I'm going to start with my standard equation here where I have to set up my givens and my finds. And I know that the formula, and there's that CF one, the adjustment factor one goes in the front of that. If I multiply CF times C times I times A. John Taylor, what is A in this example for my given? 3 acres. You always put your units behind, but it turns out that when you multiply intensity times acres, the conversion is a straight conversion to CFS. So we're going to end up with CFS over here in Q. Okay, next, Juan. What do I use for my CF? So you guys can write this down. A equals 3 CF. It's a 25-year storm. And back on this chart, right here, Juan. For a 25-year storm, what do I use for CF?
Is that 1.1?
Correct, 1.1. So you just pick off whatever storm event they're talking about, pick off your CF. That's that recurrence adjustment that they've added more recently. All right, next one. We're going to go to this chart here. Let's go to Sam. Sam, in the question they ask you, the storm event is a 25-year 1 hour. So what number do I use for I?
Looks like 2.14.
2.14, 25-year 1 hour is right there below that circle, 2.14 inches per hour. So I want to write my units there. Last one is C. C is that thing that Jason mentioned earlier. When I dump that water on the concrete, it's essentially close to a 1.0. I've got a C factor that I have to come up with. And what they do, I'm actually going to jump to a different deal here. They have a chart that you guys will be working from today, right here. This is the C coefficients, okay? And for this example that we're talking about, it's a farm, right? It says, suppose the developer does a farm, 3-acre farm. So right now we're just doing the pre-development rate, 25-year, it's a farm. So which one of these do we pick on this chart?
Farmland?
Farmland, very good. So 0.3. So guys, grab your calculators and give me what the Q pre is. So right now we're solving, we're finding Q pre. We want to find delta Q, which is delta Q equals the difference between Q pre and Q post. So right now we're focused on Q pre. So Q pre, someone holler out what it is. 2.12, 2.1186, 2.12. Everybody write it down on their board. 2.12 CFS, cubic feet per second. Let's think about that for a minute. So in the pre-development, this farm is 3 acres, has over 2 CFS running off of it without any changes to the farm. Now let's do the Q post. This is where the other class had some difficulty. They got the Q pre, that was easy enough to do. Now Q post. Same routine you just went through on your whiteboards. Give me what the Q post is. But before we do that, we have to come up with this 30,000 square feet of asphalt parking. So we have to come up with a C that is a composite. You guys have probably worked with weighting before, but when you weight something, you end up saying, okay, there's so much of this, so much of that, divided by the total. So what we want to do is a C composite. In this case, we have 3 acres total on the bottom. And Jack, what would I use here? What acreage would I put right here for the asphalt part?
Sorry, I can't really read it
We got by using glasses.
7.
30,000 square feet, right? So, but we need to put 30,000 divided by what? Who knows what an acre is? You guys remember that?
1.
43,560. So 43,560, because you got to do it in acres. Everything has to be in acres, so I took that. You guys should have that much done. Now the C factor, it gets back to this other page. What is asphalt? Anybody? Tyler, what's asphalt?
It is 0.95.
Right. So you guys see what I'm doing here? I'm building all these knowns. I've got the C factor for asphalt here. I've got the area for the asphalt. And the last question is, someone tell me what the difference. Tell me what this number is here. What's 30,000 divided by 43,560?
0.689.
0.69, let's call it. And so if it's 0.69, we have to add to that the other part. So what do? We take 3 total minus 0.69. What do we get for the other area? The remaining area that's going to be farmland. Trent, what's 3 minus 0.69?
2.31.
Very good. And farmland is what? C factor? 0.3. Use the same one from before. So you guys kind of get what's happening here. They're saying you need to come up with a C composite for what's happening between the with the asphalt added. So somebody tell me what the C composite is overall, and then we'll go forward from there. Maybe you all should just do it on your whiteboard. Just show me on the whiteboard what this answer is right here. Ignore this. Just take 0.69 times that, add this times that, and divide it all by 3. Anybody got it on the board? 0.45, looks like 0.45, everyone got the same answer? I'll let you guys check that. Take your time, 0.45. Good job, Connor. 0.45. So,
Yeah, I'll take them.
let's all agree that 0.45 is the answer, yes? You got it?
Yeah.
Good. This is where the other class got tripped up, guys. Do not get tripped up on this. C composite. Let's just pause for a second. C composite is simply taking the different factors and weighting them over the total area. So if you have a building, say, that's 100,000 square feet, then you're going to take that, you're going to divide it by 43560, multiply it by 0.95 for a building, add it to whatever the green area is. You get the idea? You're trying to break it into chunks and you're trying to apply the different C factors to it. So, last thing we got over here. Everyone should give me their answer on their whiteboard now. We have all, so here's our givens. So we've written Q post given on our journal. And we would actually solve it by writing this down and doing multiplication and giving me the answer for Q post. Q post. Okay? Everybody get this? I'm gonna make sure everybody gets Q post. Just like we did over here, we took the four numbers, we multiplied them together for our 3.
So with, so C changes it.
Yeah, CF is still 1.1, the intensity is still the same,
C though.
acre's the same. Yeah, the CC is the composite C I put, but it took the place of the C, it's right here.
And then that C2.
I'll make sure we've got the same answer. So Q post looks like it's 3.18. Is everyone getting 3? Q post is 3.18. 3.2, 3.18. CFS, that sound right? 3.18, good. Good. Everybody got that in their calculator? Jason, are you good on 3.18? Very good. Okay. Good feedback, thank you. So, the last step is right here, back to the beginning. It's a find delta Q. Well, again, taking your time and being neater than I am here, 3.18 CFS. So we have everything we need. All we need to do now is, usually you put the post second because it's larger. So post minus pre, so you get a positive number. So think about it. The water coming off of this farmland with the asphalt is 3.18. Without the asphalt, it's 2.12. So delta Q, Trey. Delta Q is what?
1.6.
1.06.
06.
1.06. So the answer you're looking for in this problem, the thing you circle heavily with pen, is 1.06 CFS. Everybody okay? What we're doing here? We're trying to figure out how much water impact there is. And they go through this, of course they use a different rainfall event for their example. But they ended up with 1.5 as their differential because they used a larger rainfall event. We just picked one off that table. Very important you pick the right intensity, the rainfall. You got to pay attention to the fact that it's a 25-year storm in this case, and that's the number you want to pull off of there. The dilemma I think you'll have in this is that then they go, what now? You know, okay, yeah, what do you do? We got 1.5 CFS coming off there. Now the engineer's been hired, gets paid $25,000 to design a stormwater system. Not only do those calculations, but design a stormwater system. Alex Stockmaster Flash, what is a alternate method to capture that 1.06 CFS? How do we capture that before our neighbor starts yelling at us and suing us?
Put more plants.
Good, or plants, that's one. What's another one, Jack?
You could if there's a hill going down, you could try and take away the hill.
Yep, a catchment, they call it. So if you have an area, like you guys, a lot of your houses, they come down like this, your house is up here, you actually create a swale where the water goes in that swale first before it goes up and over into your neighbor's yard. Connor, what's another thing we can do to capture the water? A what?
You
Yeah,
And you use it to water your plants.
yes, beautiful. You guys hear that? You can capture it and water your plants. So a lot of people will create a bioretention area where they capture it into their plant area, or they will actually take it in a holding pond and they'll pump the water out of that pond and irrigate. Golf courses do that. Who plays golf here? Anybody? So the golf courses around, they have these ponds, and those ponds actually catch the rainwater, and then they have pumps that pump out the water and water to irrigate the grass. That's all I have to say about that PowerPoint. The worksheet is here, and we got a few more minutes. The things you're going to need are your calculator and your journal. Today, this is an easy one, meaning that for documentation purposes, you do 4 things. 1, you go through this example, you use the data that's in there, you answer this question 1, put it there, answer question 2, put it there, fill in your conclusion questions here and here, upload into Canvas. You're done once you show me your journal and show me all your hang calculations. Do not take a picture of your journal. Do not ask me if you need to take a picture of your journal. It's fine today. I have proof in your journal. When you come by, I will look at it to see how you arrived at those answers.
So upload nothing today.
Upload this worksheet with those 4 things filled in, but do not leave without showing your journal. Pardon me?
Questions.
Hang on, everybody, hang on. Couple more questions. Yes, Alex.
Can we do the calculation?
Thinking, bro.
You can do the calculations in the Word document. Yes, if you want to, it's fine by me. Either way,
It's not working.
work on those. I will be available to assist you if you get stuck. Put the whiteboards up here by Sam.
Put this one on top.
It'll take you about an hour to do this lesson.
What?
What did it take me?
This one, me,
Thank you.
Field trip is on Thursday. The bus will be out front at 7:15 for the
Gosh,
trip.
where's the actual?
That one we
time?
left so early.
Isn't it
Do
on
we
the-
need a 7:15 or we need to be here then? We need to be
Let's
here.
switch to the
John,
23rd.
quiz anyone?
It's been on that day.
Yeah.
23rd, Thursday.
I don't know.
Coach, where's the actual?
It's right, 23rd. Pardon me?
Where's the actual time?
It's toward the bottom. They give you some examples and they get the 2 problems.
Oh, God.
Oh.
Oh, no, I have a test on Thursday.
Hey, there's something I failed to mention here. They have a website. Take a look up here for a second. There's a website they refer you to right here, guys. Everybody eyes up here for a second. See this website right here?
Yep.
Jason, everybody look up here. So what happens is they have these websites for different areas of the country. Do they have it for Texas? Trent, do they have it for Texas?
Apparently not.
Turns out Texas is not part of the United States anymore, so they're white. But these guys are updating their information, so if you get a question about Chicago, like you will in the first one, you click on Illinois, you click on Chicago, and you get close to Chicago with your arrow, like right there, and then you pull this down here and you select a station. They say near Chicago University. See where it says Chicago University right there?
Yeah.
Click on that. It will bring a table up at the bottom with the rainfall events. Tyler, Sam,
I got it.
you guys okay? So if they give you some obscure place like Noblesville, Indiana, which I know where that is near Indy, same thing. You'll do the same thing again. You'll go to the chart, you'll find Noblesville, you'll pull down Noblesville, Indiana, and you'll get the table here. So do not use the table that was given to you in the example. Use this table for the particular location that you're dealing with. Cedar Rapids, if they ask you about Cedar Rapids, same thing. Pick Cedar Rapids, there's several of them, pick the first one, and then find the table for Cedar Rapids, okay? So you're using these rainfall intensity maps from this website that's mentioned right there.
Wait, there's 2 Cedar Rapids ones.
Yeah, none of the questions pertain to Cedar Rapids, I'm just saying that,
Alright.
Wait, so we go to Cedar
if
Rapids?
there was, you'd want to pick the one that's closest to your site. And that would require you to know the latitude and longitude of your site, so that you can put it in that chart and it would give you the exact one to use.
Sure.
There is an example problem, guys, in the beginning that you can go through toward the top.
You said to go to Cedar Rapids.
No, use what it says in the program. I said if they did ask you, just go to the, yeah, you can go to Cedar Rapids, but it asks you to go to Chicago and to Noblesville, Indiana. Yep, then you just pick the station up there, that's Chicago University. When I was younger, they didn't have these fancy tables, these fancy computers, we could find stuff like this. So you're very fortunate, they had books you had to buy, you had to look through the book. But you guys can find this, any rainfall station in the United States except Texas and a few-
Noblesville, Morris?
Yeah, there's Noblesville, that's it, there's only one Noblesville,
Morris.
just one. So you have one for Noblesville, one for Chicago.